Here's a problem from your book. The purpose of this exercise is to determine whether triangle ABC can be constructed when two lengths A and B and the measure of an acute angle A are given. First, angle A and then the side of length B are constructed. Finally, a circular arc is drawn with center C and radius A. Given that the distance from C to the side opposite C is B sine A, determine for each of the following conditions whether 0, 1, or 2 of the triangles can be formed. I'm going to restate this problem to the following. Given two sides and an angle that is not included, go through the different situations to show if 0, 1, or 2 triangles are formed. So let's take a look at this. We have angle A, an acute angle. We have opposite side, little a, and we have little b. These two sides are fixed in length and A is fixed in length. This bottom length can be as long as we need to. So however long A is, it can extend out. We can have this whatever length is needed. This angle up at the top, which would be angle C, can also be any angle that fits the situation, and then once angle or the side A touches this the side little c, then that angle formed angle B can be any length we need to as well. What is fixed is little a, little b, and angle A. In geometry, this would be called SSA, which is not a theorem. Why? Because it does not form one unique triangle. A way to remember that is spell it backwards, and that's not something we would ever say in the class. Let's review a second the triangle congruence theorems. We have side, 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 angle, side, angle, side, angle, 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 side, and HL for a right triangle. Now all of these have three pieces of information, HL, hypotenuse, leg for the right triangle, and these all form one unique triangle. So anytime we're given three sides of a triangle and they form a triangle, there's only one triangle we could ever draw with that information. But as we're going to go through in this problem, if we have side-side angle, there is not one unique situation that can be drawn. So let's take a look and see what happens. First, I'll look at case. What happens if I have a piece like this? So I have, let's first review, what if I drew this length down there? That's supposed to be straight down, and this is a right angle, and I'll call that H. How do I find H? Well, I know angle A, I want to find H, and I know angle B. So I could say that the sine of capital A equals the opposite over the hypotenuse. So in other words, H equals B sine A. That's going to be our reference point for most of this. So if we have a situation here where that side opposite the angle, so little a, opposite the angle A, is less than the height. Let me show a diagram that I made. Now, this little a can, all we want it to do is to touch this side here, and if it touches, then we have a triangle. What happens here if I'm rotating this around in a circular arc? Will that piece, oh, you can't see it, to try to move it around, will this piece ever touch the long side on the bottom? You can see here, no matter what, as long as this piece here is less than the height, it will never touch it. And we can show that here by a little arc there. So if little a is less than B sine of A, there are 0 triangles formed. Let's look at next situation. What if little a equals b sine of a? Let me put my diagram back together. So in this situation, it's not the exact same ones we had before. So if I'm taking a look at this and I slide this around and it exactly equals the height. So the only place that it touches is when you get the height there. Again, this piece, the hypotenuse to that angle, in this case, or the adjacent leg to that angle, are fixed as well as this angle. So as I'm rotating this around, it's going to hit in one spot and one spot only. How many triangles are formed? Well, there's one triangle. If there's only one triangle formed, there must be something unique about it. Let's take a look again at our triangle congruence theorems. Which theorem is that? Well, what this is saying is I have a right angle here. I have this angle, the opposite side to it, as well as this longer side. Well, that's opposite my right angle, so this is my hypotenuse. So this is HL for a right triangle. In this one situation, there is one unique triangle that is formed. And if I was drawing a picture for this, it would look something like this. Now when I'm drawing this arc, to see where it touches, it's going to touch at one spot. Again, I have label in the sides. Well, what happens if in my next situation I have that b sine a is going to be greater than, oh, wrong one. Not if b sine, if a is greater than b sine a. So that was the first one we did. If a was greater than b sine a and at the same time less than b. Let's see what happens in this situation. This one would look like here. Let me try to get this one so it's a little bit better. So what happens when this piece here is rotating around? Let me see, first make sure. I need to fold that over a little bit more. Okay. So I hit one time, so it's longer than the height here, and the height will just be to this point. When I'm rotating it around, it's going to hit once here, and then what happens as it's coming around? It hits another time over there. So this arc hits compared to this angle, this opposite side, in two places. That's telling us that two different triangles are formed. Let's draw a picture of that one. Again, I'm going to go through my standards. And then when I'm drawing this arc, I can pretty much, let me see if I could do it kind of like this. Almost. Probably be better if I just did it freehand. Yeah. I think using the ruler made it a little bit too much there. So you have this arc that's coming through, And now I have two triangles. 1, 2. Let's redraw those triangles. This first one looks like this, or the second one looks like this. We still have the same fixed measurements, A, B, and my picture here on the right is not drawn perfectly. That's okay. But this little a is congruent to this a, little b's are congruent, and angle A is the same. So in this situation, two triangles are formed. Now let's look at the last situation. What if A is greater than B? Let's see what that one would look like. I need to extend this one out a little bit. So if it was greater, I can hit it here. As this, so let's say we have one hits there. As it comes around, move my triangle so I can. So as it comes around, will it form another triangle? When it hits the bottom line, it's going to hit it outside of the triangle as this arc sweeps around. So what's happening here is one triangle is formed. And let me draw it on the paper and we'll see if we can take a look at this. So I'll exaggerate it a little bit. When that side here, if it comes around, it's going to be coming around over here. Well, if that were the case, that's no longer the same as this angle A. It would be the supplement of that. So if the side opposite the given angle is bigger than the side adjacent to the given angle, one triangle is formed. So to summarize this, when we're given a situation of two sides and an angle not included, what we need to do is we need to look at, compare the lengths to the height to determine, is there going to be zero triangle formed, one triangle formed in either of these two situations, or two triangles formed. And that is why SSA is not a theorem, because it's not giving us one unique triangle. We have to be very aware of this when we're solving problems, because you have to determine, it won't be told to you, you have to determine if there's one, two, or zero triangles formed. If there are two triangles formed, you must find all the information for both triangles. And on the next video, I will go through an example of that.